So far, we've learned how to find the x-intercepts of a parabola, or a quadratic equation, or a degree 2 polynomial function. All those mean the same thing. We've learned how to algebraically find these specific points where our graph hits that x-axis. Well, now we need to expand on that, and we need to start learning how to actually graph a parabola given an equation. Well, before we start graphing them though, we need to learn some key features of a parabola. So the first key feature that we're going to talk about today is what we call the vertex. So the vertex of a parabola is the highest or the lowest point on the parabola. So for example, if you have a parabola that's upwards facing like this, then your vertex is this point. But if you had a parabola that's downward facing like this, then your vertex would be this point. So as you can see on our upward facing parabola, all of the points on the parabola are above that point, that vertex. So that point then is what we also call the minimum. So you can also call it the minimum. If it's the lowest point, it's the minimum. And likewise, if you look at our parabola over here, here's our vertex. All of these points, oh, I just erased that apparently. Sorry. Excuse me. All of these points are below the vertex. That vertex is the highest point on our parabola. Therefore, that vertex is also the maximum. It's the maximum. So when we talk about the vertex is a point on the parabola. So when we talk about the vertex, we're always going to write it as a point. So you want to write as a point with an x and a y value. We refer to the x value as h and the y value as k. So h is just the x value of the point, and k is the y value. So now we're going to look at some parabolas, and we're going to identify the vertex of the parabola. We're going to talk about if the parabola is positively or negatively oriented. We're going to talk about if the vertex is a maximum or a minimum. So if a parabola is upwards facing, we refer to that as positively oriented because it's facing the positive y values. So positively oriented. If a parabola is downwards facing, like this one is, then we say that it's negatively oriented because it's facing the negative y values. And we'll talk about what that really means in just a minute. So this one would be negatively oriented. Why isn't my tablet, there we go, recognizing my finger when I'm trying to scroll? Okay, so here we have some examples of parabolas. In example 1, we have 3 different parabolas. So we're going to talk about the vertex, whether it's a maximum or a minimum, and if the parabola is positively or negatively oriented. So as you can see, the highest point on this parabola, the vertex, is right here. So at this point, we have our vertex, and we're going to write it as a point, an x value and a y value. So the x value of this point is 2, and the y value of this point is 3. So the vertex is at the point 2, 3. Is this point a maximum or a minimum? well, is this the highest point on the graph or the lowest point? So as you can see, the points right here, all of the points on the parabola are below that point. The rest of the points on the parabola are below that point. So because of that, we say that this is a maximum. Then, is this positively or negatively oriented? So as you can see on this parabola is extending forever in the downward direction. Well, all of the negative y values are in that same downward direction. So this parabola is facing the negative y values. So we say that this is negatively oriented. So now what I'd like you to do is complete the information for the next two parabolas. As you can see here, we have two more parabolas. Tell me what the vertex is. Tell me if it's a maximum or minimum. Tell me if it's positively or negatively oriented. Pause the video and then press play when you're ready to check your answers. Let's go ahead and check your answers. So for the second parabola here, we have our vertex at the lowest point, which means that it should be a minimum. The x value of that point is -3, and the y value is -2. So the vertex is at -3, -2. I'm just going to label that this is a vertex. It's a minimum, and because this is upwards facing, we know that it is positively oriented. For our third parabola, our vertex is at this point. It's the highest point on this graph. All of the other points are below it, so we know that it's a maximum. And it's also downward facing, so we know that it's negatively oriented. And then for the x and y value of that point, the x value is 0 because it's on the y-axis, and all the x values on the y-axis are always 0. For the y value then, it looks like they're counting by 2s, like if this would be -2, -4, -6, -8, -10. So this point looks like it's halfway between 0 and -2, so it must be -1. So the vertex is at the point 0, -1. It's a maximum, and it's negatively oriented. Moving on to the next part of our notes. For some reason, it's not letting me scroll. Sorry. All right, so for example 2, we're going to identify the x and the y intercepts of each parabola. So for the x-intercepts, we're looking at where this parabola hits the x-axis. So for our x-intercepts, we have a point here and here. These are my x-intercepts. And then our y-intercept is where we intersect the y-axis. So our parabola intersects the y-axis at this point here. So for identifying the x-intercepts, it looks like we're going to have decimals. So we have 2 x-intercepts. At every x-intercept ever, we know the y value is always 0. So we can fill in the y value of each point. And then for the x value, so this x value is between 3 and 4. It looks like it's about halfway between, so we're just going to go ahead and say that it's 3.5. For the second x-intercept, it looks like we are between 1 and 0, and maybe a little less than a half. So I'm going to say we're at about 0.4. So when you have to estimate like that, it's okay if you had said that that was 0.5 or 0.3, I would accept both of those answers. Like I understand that we are estimating those decimal values, and that's okay. So then for the y-intercept, we are clearly hitting the y-axis at 0, -2. So that's our y-intercept. So your x-intercepts and your y-intercepts are just the points where your parabola is intersecting the x-axis or the y-axis. Usually my tablet recognizes that I'm trying to scroll with my finger, but it's not working today for some silly reason. So for the second and third parabola, why don't you guys go ahead and pause the video, identify the x and the y-intercepts without me, and then press play when you're ready to check your answers. So for the second parabola, our x-intercepts are right here and here, and our y-intercept is there. So our x-intercepts are at 2 points, and then we have one y-intercept. The x-intercept, this one, the far left one, it looks like it's at -5, 0. And the far right one is at -1, 0. And then the y-intercept is at 0, 2. Now let's do the third one. So this parabola doesn't actually hit the x-axis. So we have no x-intercepts. So no x-intercepts. And that's perfectly fine. Because remember last week we learned how to deal with that. That means that the x-intercepts are imaginary. So we should say no real x-intercepts. There are 2 imaginary zeros. And we learned how to find those last week. So when we get into actually making the graph ourselves, we'll understand that we don't actually hit the x-axis. Then we have a y-intercept. And that y-intercept then is at 0, -1. So far today, we've learned about some important features of a parabola: the vertex, the x-intercept, and the y-intercept. The next important feature that we need to talk about is the axis of symmetry. So I'm actually going to show you what the axis of symmetry is on the very first example before I explain what it is. So if you find the vertex of the parabola, do you notice something about this half of the parabola versus this half of the parabola? Don't they look the exact same, but one is just reflected over to the other one? They're like a mirror image, right? So if you drew a line, a dashed line through the vertex, that line splits this parabola perfectly in half. And that line takes this half of the parabola and reflects it over to the other half of the parabola. And we call that line a line of symmetry. And when we talk about parabolas, we call it specifically the axis of symmetry. So this line I just drew, I'm going to highlight it in pink. This line, this dashed line, we want to make sure it's dashed. Always make sure your axis of symmetry is dashed. Divides that parabola in half. So the axis of symmetry is a line that divides the parabola in 2 symmetrical halves. The symmetrical have 2 M's. Y'all aren't here to help me spell. 2 symmetrical halves. And whenever we talk about the axis of symmetry, we want to make sure we write it as an equation. So you're always going to write it as x equals a number, some number h. Well, where else did we refer to x as h? Remember when we talked about the vertex earlier and we understood that it's a point hk, where h is the x value and y is the k value? Well, the axis of symmetry is the line where x equals h, and h is the x value of the vertex. So what was the vertex of this parabola? Well, the vertex is this point right here. And that point had the x value of 2 and the y value of 3. So h is 2, which means the axis of symmetry is x equals 2. And sure enough, where does my dashed line hit the x-axis? at 2. So the axis of symmetry is the line x equals 2. So let's do the second example together, and then I'll have you do the third one on your own. Excuse me. Having some scrolling issues today, sorry. So in the second parabola, here's my vertex at -3, -2. If I draw a vertical line that goes through that point, that vertex, well, where does that line hit the x-axis? At -3. That means that my axis of symmetry is the line x equals -3. And that x value, x equals, matches the x value of the vertex. That's not a coincidence. That's how this works. So why don't you go ahead and figure out the axis of symmetry on your own for the third one. Pause the video and then press play when you're ready to check your answer. So if you notice, the x value of the vertex is 0. The y value is -1. If you draw the line of symmetry, the line of symmetry is the exact same thing as the y-axis. Well, the y-axis happens at x equals 0, and our axis of symmetry is the equation x equals 0. And that's it for today's notes.